Hey there everyone, welcome to the final review for this semester. It's titled Unit 5, but I'm realizing now that this probably was like Unit 2 or something. It doesn't matter. Let's just start. We're going to go over parent functions and transformations. So things that have been applied in other sections, but this one's just more of a general unit so that you have multiple functions. Here you can see you have a linear function. Here we have a quadratic function. Here we have an absolute value function. So whereas the other units focus specifically on just one type of those functions. So yeah, that's all we're going to do. The transformations are pretty similar across function types though. So identify the following functions to its parent function and state the transformation. All right, so, well, this is a absolute value function. I know that it is an absolute value function because it makes the V graph. Anything that makes a V graph will be an absolute value function. All right, so where's this vertex at? Just read this graph. Down here is the vertex, and it's going -4, 5, 6, 7, 8. So it's going 8 down, and then you can clearly see it goes -2 across. So you're going to say -2, -8. Axis of symmetry goes through the x coordinate. Min-max goes through the y coordinate. Is it a min or a max? You can see that it is the lowest point, and it's going up. So it is a minimum. All right, what's the domain? All real numbers. How do I know that? Domain is, can it move freely left and right? Is there any restrictions? No, there is not. The range, what is the restriction on the range? The range's restriction is that it can only go as low as -8, and then it's going to go up forever. So I'm going to say y is greater than or equal to -8. You could also write it as -8 in a bracket, and that's going to go up forever, so parentheses around the infinity symbol, okay? So, 2a, graph the transformation to its parent function and describe the transformation. Let's describe this transformation first. First of all, this is a linear function. That +4 makes it go up 4, okay? So up 4. That's all you have to say there. And then how do you graph this? You can plug in a bunch of values to the function, or just plug this in and press Control-T. Once you pull up a table of values, then you can graph it. So that's what I'm going to show you. I'm going to show you screenshots from me making a table and graphing those table values. All right, so look, I have these values graphed. I went -2, 2, -2, 2, -1, 3, -1, 3, 0, 4, 0, 4, 1, 5, 1, comma 5, and 2, 6, 2, comma 6. All right, so that's all there is to it. Let's identify the domain and range. So the domain is all real numbers. So you can say like that. I put 2 blanks for additional ways you can write all real numbers. You could write the words all real numbers. You could say, there's several ways. You could say -infinity to +infinity with parentheses. And then you could also say that it's -infinity x is less than x, which is less than greater than, or less than +infinity. So those are the different ways you could write all real numbers. I like the R. It's less writing. And as you can see, I don't always make that infinity symbol look very neat. Okay, so the range. The range is going up and down forever, so it's the same answer. You could say all real numbers. You could write it like this. It doesn't matter. I just want to make sure you don't forget what the different notations look like, okay? So moving on to 3a. Graph this transformation. Okay, that's what this all is. So this is a quadratic function. What is the transformation? That -1 makes it go down 1. So let's look at the graph now. Okay, so here you can see that the vertex typically starts at 0, 0, and it went down 1. That's what it means by down 1. I failed to point it out on this one. We said that the transformation was up 4, and so normally it starts at 0, 0, but look, it started at 1, 2, 3, 4. It went up 4. See? So that's how you can tell if you get stumped, you look at the graph, and the graph can tell you the answer. Okay, that being said, these are the points that I graphed. You see 0, -1 right in the middle. That's where the vertex is. -2, 3, and you see 2, 3 as well. So yeah, I had that nice round the parabola. Let's see here. So let's write our domain. My domain is all real numbers. My range is, the lowest point is -1. So I'm going to use interval notation. -1 to infinity, because it's going up forever, okay? Keep in mind, you could also say y is greater than or equal to -1, okay? All right. This is an absolute value function. What is this transformation? It is going right 5. So right 5. Okay, now let's look at the graph. Okay, so you can tell by looking at the graph that it starts 5 over to the right. So what points did I graph? See, look, 5, 0, that's the vertex. And then I graphed 3, 2. So I'm going 3 across, 2 up, 4, 1, 4 up, 4 across, 1 up, 6 across, 1 up, 7 across, 2 up. Okay? So let's write the domain in interval notation. So -infinity to +infinity. Again, I'm just going through this just so we don't forget about it. I don't really have a preference. Just let's say you're taking a standardized test or something like that. I don't know how they're going to write their answer, so I wouldn't want you to forget what the other symbols look like, what the other notations look like. So the range here is going to go from 5 and up. So y is greater than or equal to 5. Okay, or start at 5, put a bracket, go up forever, put a parentheses. Okay, moving on to number 5. This is a quadratic function, -x squared. So that -x squared is going to make it reflect over the x-axis. All right, so it's reflecting over the x-axis. How do I know that for sure? Let's look at the graph. So here, looking at the graph, you can see that it is opening down. It's going into the negative part of the y-axis. It's still starting at 0, 0. It didn't move up, down, left, or right. It reflected over the x-axis. The reflection over the y-axis, you wouldn't even be able to tell the difference because it would be reflecting from side to side instead of from top to bottom. So yes, here are the points I graphed. Go -2, down 4, -1, down 1, 0, 0, 1 across, 1 down, 2 across, 4 down. That's all there is to it. So the domain, I'll write it like this, from -infinity less than x, which is less than +infinity, or maybe you want to write it with the all real number symbol. The range, let's see here, it's going from 0 down forever. So y is less than or equal to 0, or you could say that it is going down forever. That's the smallest value first, so -infinity first and 0 second in a bracket. Okay, so that's all there is to say about that one. Number 6, identify and correct the error in describing the transformation of the parent function. All right, so we have this negative quadratic function, just like this, -x squared. So let's see what they say. The graph is a reflection in the x-axis and a vertical shrink of the parent function. All right, so is it a vertical shrink? Well, it is starting at 0, 0, And then let's look at how it's graphed. There's a blank, there's a 4, there's a blank, there's an 8, there's a blank, there's a 12. So it looks like it's counting by twos. 2, 4, 6, 8, 10, 12, 14. But the x's appear to be going by ones. 1, 2, 3, 4. So we can clearly see it's a reflection in the x-axis. We just did one. We're just trying to verify, is this a vertical shrink? Meaning, is it wider? Is it being pushed down vertically? So the points here are 0, 0, -1, -2, and 1, -2. And then it goes from -2 down to -8. So these are the points that you can easily identify. Let's look at the -x squared one. If it went -1 down to -1, here, let's look at the table with it too. And then it went -2 down to -4. So here, it went from -1 down to -2 and -2 down to -8. So you tell me, is it vertically shrinking or vertically stretching? Because I think it is actually a vertical stretch. So I'm going to cross that out and write vertical stretch instead. Okay, so I wrote that below. I'll put a check mark by this reflection in the x-axis because that was true. I don't want y'all to think that that part wasn't true. So that's it. That's it for this review. Good luck on the test. Remember, you can write down anything you want on a regular sheet of paper, regular size sheet of paper, 8.5 by 11 inches, okay? If you have any questions, leave a comment below, see me in class, whatever. Like and subscribe if you feel like it. Okay, goodbye.